First of all, I want to welcome officially to the department and University of São Paulo. I want to thank you for being here. And we're very happy to have you here, and we are very eager to engage in processes with the representation. And yeah, thank you.
All right. So thank you, Tiago. Good morning. It's a great pleasure for me to be here. It's the first time for me to be here at USP. Thanks to Tiago for the invitation. We met us 2 years ago, the first time in Campinas, when Tiago was working at the University of Campinas. There was an event called Diplomacy Science, and we meet us and we discussed, and we had also nice discussion about collaborations of Brazilian and German universities, and we are still in contact. And so I asked Tiago if he has time and if he can organize a session for me here at the university, because I'm visiting Brazil every year. Last time I was in November last year, so this time I'm here now. So coming back every year to Brazil, and it's very, very nice to be here, and also to have the opportunity to make a short presentation about my university, my areas of interest, and then maybe we can have a discussion of what we can do in the future. So my name is Paul. I'm professor of industrial engineering at Hof University, with the focus on efficient, digital, and sustainable production, I would say, and especially in the combination of these three areas. That's my general interest, and I'm responsible for the industrial engineering program at the Hof University, and also when it comes to international relations of the engineering department, I'm also the lead of it. So today, or now, I want to talk about the first two topics. So to give you a first introduction about the university, and then we are talking about the industrial engineering department, the study programs, what we are doing, and introducing you to my lab, the Smart Factory Lab. And then we are having the second session also for the students, where I want to focus on the topics 3, maybe also on topic 4, depending on the time, which means Industry 4.0 and smart factories and products. And maybe if we have time, also on a specific topic, remanufacturing. It's a part of the circular economy where you can reuse products that have already been used, like, for example, engines in cars. You can take them, you can clean the parts, you can do a process of reconditioning, and you can reuse the product once again. So I'm fighting here against a mosquito right now, but that's fine for me. So we want to start with the introduction of Hof University. First of all, where is Hof University? It's located in Germany, in the heart, in the center of Germany, I would say. So we are having here Hof University in the center, in between of Frankfurt, Munich, and Berlin. Berlin, the capital city of Germany, with the Brandenburger Gate, and also all the government, which is located in Berlin. Munich, it's the hometown of beer, so where all of the beer companies are producing the beer. Also BMW is located in Munich, and Frankfurt is the capital city of finance in Germany. And Hof is in the center of it, round about 2 hours of driving by car away from these all three cities. So it means if you want to study, you have Hof as a perfect location. You can focus on your study, and on the weekend you can drive to the cities and enjoy the life and also the nightlife in the big cities. Hof is also the advantage that has very cheap living costs in comparison, of course, to the big cities around, which is almost doubled from the price perspective. And if you want to visit also other countries, Prague is also 2 hours away. You can fly to Paris, 1 hour of flight. You can fly to London, 1.5 hours of flight, so really close to all these big cities in Europe. So this is Hof University. Hof University is a university of applied sciences. That's a special system in Germany. We are having, I would say, more research-focused universities, which is, for example, Technical University of Munich, which you have also a collaboration with, which is Darmstadt. And we are having University of Applied Sciences, where we focus more on the education of applied sciences. We have a lot of lab works included in the study program. So nearly all the classes, they include lab work. They include some teaching on the machine with software. So directly what is necessary for the industry. That's the main focus of these universities. And this means that the classes are smaller because we need to coach the students. We need to supervise them. All the students, they work on milling machines. They work on turning machines. They knew all the processes for manufacturing technologies. They work with different kind of softwares. So we need to supervise them. This leads to smaller classes and to less students because it's more of effort for the professors to coach the students. Hof University was founded 30 years ago, and Hof University has also a lot of international students. We're having more than 1,000 international students from different countries around the world. The biggest focus is right now India, because we're having the Bavarian Center, Indian Center in Hof. And we are also expanding to Latin America. We're having a lot of students from Mexico right now, from Colombia, from Peru, and also from Brazil. And I'm also teaching right now a student from USP, from San Carlos campus, which is one of my students this semester in my class. So relatively modern university. It's a tech university where we focus on different kinds of technologies. From the study programs, we are covering the traditional engineering fields, starting from mechanical engineering, industrial engineering. We're having also some specialties, like, for example, textiles engineering, which is very special. That's a building for textile engineering with big textile machines. We're having sustainable engineering, but we will see an overview of all the study programs in some further slides. And during winter times, we also have snow. Yeah, that's very special for Germany, so the temperatures can rise below zero. So we are having also a lot of snow, which is very special for a lot of students, for incoming students who are coming to Germany. So to see snow and to play also with snow. The university is open 24 hours, 7 days a week. So the students have all the time access to the universities. During the weekends, of course, we do not have classes, but they can use the library, they can go to the labs, they can work in groups, so it's very, very flexible to the students. Hof University was elected in 2023 and 2024 to the most popular German university of applied sciences by student votes. And we have system of accreditation and stuff like that, but I think that's not the main point for today. What's important is our study programs. For our study programs, we have a bachelor program and a master program. That's a European system. That's a Bologna process we had some years ago. So here in total, the students, they need 5 years. So that's similar to your undergraduate program. But we need to divide it to a bachelor program, 3.5 years, and a master program. And the biggest study programs are engineering science, where we covered all the core disciplines of engineering, which is electrical engineering, mechanical engineering, material science, and industrial engineering. We had the study program separately before. We combined them together just to make more, to have a bigger efficiency when performing the study programs and to give the students more flexibility. So it means the students, they are starting in the first year all together, and then they have to select what they want to study. So sometimes the students, they said at the beginning, I want to study mechanical engineering, but after 1 year, they get the feeling, oh, maybe industrial engineering is better for me. So they have 1 year time to make the decision what they want to study. Gives the students, of course, more flexibility. These are the 2 new study programs we are starting in October this year. It's the engineering science, which I'm responsible for, and environmental engineering, which a colleague of me is responsible, which are both completely taught in English. It means we are doing a clone of the German engineering science to English engineering science, where we want to include also exchange students. We want to include in general students from all over the globe. And we want to do double degrees with the study program, which also is related to the environmental engineering. Then we have some specialties, what I said, textile engineering, textile design. And when it comes to the master program, I think the most important is the international project management study program, which is good for most of the industrial engineering students and also mechanical students when it comes to the general topics of project management. When they go to companies, they have to lead projects, so this is a good choice to go. And we are starting next year also our industrial engineering master program, and the mechanical master program will be also switched to English. And then we have some also additional special programs like sustainable water management and engineering, which focuses on the environmental engineering with aspect of water. And what's not here in the list, we have a program which is called AI and robotics. AI and robotics is a combination of engineering and computer science for both students. And in AI and robotics, I'm also having right now the students of San Carlos. All right, so this is the overview for the undergraduate, for the bachelor program of engineering science. We are having 3.5 years, completely taught in English, as I've mentioned. And the key areas are industrial engineering, mechanical engineering, and automation. In this engineering science program, the students can also select a lot of classes, what they want to do. So they are starting in a general, this is the overview, they are starting in the first and second semester with a general, with the basics, I would say, like mathematics, mechanics, business management, material science, electrical engineering, and then going to a special phase, what they want to focus on. We've included a lot of electives in the study programs over the study program in general, just to be able that the students can select what they are interested in. So if the students want to have more classes about simulation or production engineering or supply chain management, they can choose it. If they are more interested in automation, robotics, AI, they can choose it. If they are more interested about product development, they can choose it. So a lot of classes are here electives where the students can choose the direction where they want to go, what they want to study in particular. Some of them are also predefined because we need to define a preset. This is the bachelor part, yes. Correct. Yes, yes, yes. So the system is that we are having 3.5 years of bachelor, which is the 7th semester. And the last semester, this is also a special approach of the University of Applied Sciences. They have to do it in industry. So they are going to an industry company, to a manufacturing company, and they are doing like a project, and they are doing a project work in the company. And in parallel, they are doing the bachelor thesis. So 3 years at the university and half of a year, 1 semester in industry. And then they can do the master program, but for the German student, it's not necessary. They can also go directly as a bachelor engineering graduate to industry.
I'm not very familiar with the German system. This is the structure for an applied sciences course. Which is the difference between the university course and the applied, or the Hochschule and the university?
Yes, it depends on the region, because university is related to the government of the region, not of the country. So for example, for Darmstadt, which is not Bavaria, they have different rules. The general difference is you don't have the project work and the bachelor thesis in industry. That's the main point, which is the difference. You're writing more on a research project, your thesis. This is the regular university, the research universities, and the applied sciences. They want to send the students to the industry. That's the biggest difference. And also that we include in nearly most of the classes practical work. So means if you have manufacturing technologies, you will work on a drilling, turning machine, you will do cutting, sawing, and so on. If you have, for example, automation and robotics, you will program a robot. So you have more work in the labs. That's the biggest difference between the research universities and the universities of applied sciences. What we also include here in this program is a German training. Also for our exchange students, they can do some German training if they want to, but it's not necessary. But we recommend it. And for this program, we want to include also double degrees. And we are starting also double degrees with the university in Puebla in Mexico for this. We are going to extend this also for the German Vietnamese university in Vietnam. And then we are taking also, or we are discussing also to include further university to this for a double degree, especially in the semester 5th and 6th, or they can come also to the 7th semester, and if they want to go to industry and do a internship at the industry, also supervised by the university. This is also possible. Of course, if you have students in the year 4th and 5th, they can be included in the master courses of what we are offering. All right, so this is the general introduction about Hof University. And this is the introduction of my area, what I am doing. And I've also already explained it that I'm focusing on the combination between the efficient production of lean production, digitalization, and also sustainable manufacturing. Also in the combination of two areas. So for example, how to make a sustainable manufacturing very efficient, very lean. How to use digital technologies to improve sustainability in manufacturing, or how to use digitalization to be more efficient. In some cases, we can combine also all these three areas together. We created a smart factory lab, or I started 2 years ago to create a smart factory lab. And this is what I said, that we do also practical training with the students. So we are having here a storage. We are producing cars of Lego, and we are having different assembly stations here, step by step. Then we have a quality inspection. It goes to the customer. And then we have also the recycling. So it means the last station is a disassembly station, and all the parts go into the boxes. And then we can train with the students lean management, for example, or lean production. We can discuss about what kind of informations are necessary at every station. They need instruction. We have different variants of products, for example. We need something like a production planning. We need to display all the instructions. We need to collect data. So we have RFID. We can display all the information. We can collect data. And after the collection of data, we need to analyze them. So we are playing games with the students, for example. And then they are learning step by step by doing this, not just listening, just reading some text. So they are discovering the technologies by themselves, and they are also extending the lab. So last semester we had a student group. They had the idea we can do AI-based camera quality inspection of the Lego cars. So they placed here a camera, and the camera was scanning the parts or the cars, and then it detects if the car is a good car or if there are any issues with the car. What else? We have also an automated production line. So the students need to build this from scratch. So first step is we are having 5 different process steps. They need to design the assembly station. computer-based. Then they need to build this with all these pieces, with all these motors, for example, conveyor belts. And then they need to program it, that everything is run automatically. So they need to do PLC programming. They need to talk to the other groups how to connect the station, because previously every student group was designing and creating their own station, and now they need to connect it. And at the end, we need to connect also everything together and collect informations about the station. So for example, throughput times, availability, and to display it. So like a real modern production is working. So the focus of this lab is to empower the students to discover these technologies. We are doing everything in real world, but we are transforming everything also into a digital world. So we are creating also a digital twin of the production line. We are exchanging the information of the running production to a simulation, doing simulation runs, and giving information back to the real system. We are planning everything here also in 3D, for example, with scanning technologies, like 3D scanning of rooms, of areas. And the students, they can discover these technologies step by step. We have virtual reality, augmented reality to see also the plannings in a digital environment. And we have also automation technologies. So everything from sensors, from collection of data until using, for example, AI to analyze the data is included in this lab. And the students, they are discovering all these technologies step by step during our study program. Here I brought some videos of last semester student projects. So the first student group, they received a drone to fly above the university and to scan the university, to create a replica of the university, and at the end they printed it with 3D. And this is the video. So they received here the drone. In the first step, we need to took a different building, not our university, due to rights. We need to clarify to fly over the university, which took 6 months. So the first approach was, I know Germany is not that easy if it comes to legal regulation. So we took a building of one of the students' uncle, and they scanned the building, but now they are scanning the university. So they create the route, how to scan around or how to fly with the drone around the building, what kind of scanning technologies are possible. And then they flew multiple times around the building. And afterwards, they created like a replica, 3D digital replica of the building. You can see this is the replica. You can shorten it, focusing on the building, on the aspect, what you want to have. You need some reference points. And then you can do all the measurements. And if you want to plan, for example, a factory inside, you knew all the dimensions, and then you can place all the machines inside a factory. And we are now also flying inside the university of a machine hall to scan also the shapes of the machine hall. And as you can see afterwards, they scanned the building. They printed it as a 3D model in a 3D printer to create a replica of it. So this is what I've mentioned with University of Applied Sciences. We try to do a lot of individual projects with the students. For this, we had a group of 3 or 4 students working 3.5 months. And the biggest issue was the problem that we were not allowed to fly over the university, which took 1 month of project work. So the next one was what you saw, like the big production line, the automated production line. It's an advanced project. We wanted to start with a small automated production line, showing the students of the first semester and second semester what industrial engineering in combination of automation is related to, and they build like a demonstrator how to use all the tools and to demonstrate how to create an automated production line for the students. So they connected everything together. We have a camera detection. So you're putting here coins in different colors. Then we have a sensor which detects the color and is doing a sorting between red and yellow pieces. Another project was an international project. As I said, we are also having connection to different countries in Latin America. It was with a Mexican company. They are doing some repair work for these big construction machines. And they need specific parts for these construction machines from Caterpillar, for example. And the availability of these parts is limited in Mexico. So the idea was, is in Germany or in Europe or somewhere else in the world a market to buy these parts, to maybe do like a reconditioning of these parts and to send it to Mexico, that they have all these parts stored and an availability of maybe 24 hours to bring the parts to the customer. So the students, they search for all the parts, they checked about the logistic, the supply chain, how does it work, what kind of costs do we have, how big is the market of these used products in Germany, in Europe, and Asia, and what kind of parts can be used for buying for sourcing in Europe or sourcing in Asia, shipping it to Mexico and use it there to repair all these construction machines. Another one, it was related to 3D factory planning. So this is a software tool where you can import all your data about how to, about your production process, your amount. This is the production process of all the different products in the factory, about the amounts. And then you are placing all the machines and creating the best layout for the factory. And we do some of these projects also in combination with industry, and the students, they are aware to work also with stakeholders from industry, which prepares them for a career also in industry, which is, I think, very, very beneficial for the students in totally. So you can see all the material flows inside the factory. You have in the background also different calculation about the cost of the transports, and then you can visualize everything at the end. Yeah, and we created also a digital twin. So the production line, the automated production line, what you saw before here, this one, it's also in a simulation environmental. We have a connection between the sensors here in the real world, and we bring all the information to a simulation model to create like a digital twin. And furthermore project, this is a scanning project. We took iPads, and in an iPad you have a LiDAR scanner. In the iPad Pros, you have a LiDAR scanner. Also in the iPhone Pros, there is a LiDAR scanner. It's like the very dark dot here. And with this, you can scan, for example, rooms. And we scanned, for example, here one of the classrooms, and then we created like a digital layout of this room. We use afterwards VR technologies to transfer all these views into VR. And yeah, I think this is in general all the focus areas: AR, VR, decision support system, digital twins, big data, artificial intelligence, and automation. All these are the areas which we focus on. Okay, coming to possible collaborations, what we can do. We are offering every year one COIL, which means it's a collaborative online international lecture. You can see there's already a Brazilian flag. It's a previous university of Tiago, which is now included the University of Campinas. We're having right now Hof University. We're having the University from Mexico, from Campinas, and one from Costa Rica. And we are doing a session or a course which takes 2 months. because we need to overlap it for all these countries. And it's a period from October, beginning of October to end of November. And every week, one different professor is doing one class and giving to the students like a homework. And then the students from all these universities, they are assigned to a group and they need to collaborate. They need to solve the homework and submit it. It's checked by the professors. And if you did this for all the session in the 2 months, we are having the session every week. So it means around about 8 weeks, 8 sessions, 8 homeworks. If you have done everything, you will get at the end a certificate. And this is what we can also include here. USP, for example, we will have also in the next year one university from Lima, from Peru, which takes parts, and it's an open course in the area of production systems, logistic, supply chain management, sustainable production. So it's general, very open to the topics. The main point is to get the students into interaction. And we're having around about 20 to 30 students from every university which participate in this course. And then we have mixed groups for the students, and they have to work on the homework. They have to solve one specific issues. Sometimes they need to present it, and then they will receive one certificate. So this is the first step where we can do a collaboration, an online common class. We can do it here in this topic. We can do also a separate one, depending. If we have a similar subject, we can also have a bilateral call. This is also possible. Second point is student exchange in general. Third point is we can talk about double degrees, how we can include this and where does it fit best for your universities. We're having every 2 years an international teaching week where we invite professors from different universities for 1 week doing some classes. We had last International Teaching Week 2 years ago. It was under the subject AI, but it was very generic. So something about AI for all the disciplines, independent if it's in engineering, it's computer science, business. So sometimes they are related to one buzzword, for example. What else can we do? We also have individual student projects that, for example, if you have a class with some students and I'm having a class or some of my colleagues have a class, they can collaborate together and work on a specific topic. Even, for example, on some research projects or on some industry cases, whatever fits for the professors best. And yeah, I talked slightly more than 30 minutes. So I think we can use the rest of the 20 minutes, what's remaining, just to discuss what kind of possibilities do we have when we start our next steps of our collaboration. So first of all, thank you for listening to the introduction of the Hof University and also my topic areas. And I think now we can proceed with the individual discussion.